We will be starting with the bottom end of our engine, and in this video we'll sketch out the necessary contours for the extrusions to block out our design. Now first create a new part using the part template from the My Template tab. Save and name the file to a location of your choice. I will name my file as 01_01_ flywheel sketch. Saving up front is a good practice and will allow us to simply do a keyboard Ctrl+S to save as frequently as we deem necessary. My preferred method of starting a sketch on a plane is to left click on the relevant plane icon within the feature manager and then select the sketch command from the context toolbar. Feel free to use other methods covered in the Essentials course if you prefer. Now let's start a new sketch on the front plane. I'm starting on the front plane since this is the orientation I want my front view to be when doing a drawing of this part. Since this is our first feature, the graphic view will automatically rotate normal to our screen. Subsequent features will not rotate normal to our screen, and we will need to use the normal to command when needed. We will always use our origin, the two red arrows found at the center of our graphics view, as an anchor point in some way or another. This is a good practice and will make fully defining or constraining our sketches easier. Select the circle command from the mouse gesture wheel and sketch a circle with its center point constrained onto the origin. When sketching in SolidWorks, we do not concern ourselves initially with the exact size of our geometry, since we will capture our design intent after the required profile is complete, with either relations or dimensions. With the circle in place, let's sketch a vertical center line with its start point on the origin, which we will use to establish both symmetry and the height for our next profile. With this in place, let's sketch the next profile. Follow my lead, and again, don't be concerned about exact sizing. Right mouse click in the graphics view and select the center point arc command, and at the top point of the center line sketch an arc similar to this. Next, sketch the two lines joining the arc and the circle. Next, add a tangent relation to the circle and left vertical line. Simply select the circle, then Control select the line, and from the context toolbar, select the tangent relation option. And do the same for the right hand line as well. To select the two lines, I could instead left click and drag my mouse from bottom right to top left, making sure I'm touching the circle and line, which is a more efficient way at times. Note that I don't move my mouse after the selection, so I can make use of the context toolbar instead of having to go to the properties tab to make these selections. It is far more efficient. Now do the arc points as well in the same way. I'll do the left side first and then the right. Select the three vertical lines, dragging from right to left again. Since we have two solid lines with a center line in the center of the two, our context toolbar will now also have a symmetrical relation. Select it to make the three lines symmetrical. Sketch a center line horizontal between the two solid vertical lines. Right click on the horizontal line so we can use the select midpoint command. Then Control select the vertical line and select the make midpoint relation. We do this so these lines intersect exactly at their centers. We will be using the horizontal line later as a reference. Grab the center point arc command again and sketch an arc as follows, making sure the start and end points are 180 degrees perpendicular to the origin. And with this arc in place, join the arc points to the circle with a line on each side to close the profile. We have completed the necessary profiles, and in the next video we will add the necessary dimensions. Now that we have our completed profile and the necessary relations are captured, we will add the necessary dimensions. Let's say that the design intent is that the center circle dimension will be our driving dimension, to which the other profile dimensions within the sketch will be related. To easily capture this, we will use equations for our dimensions. And this will allow us to later change the circle dimension, and all other dimensions will update automatically, keeping the scale of the other profiles or contours in scale to the circle's size. With the dimension tool selected, first add a dimension to the circle, and in the modified dialog that pops up, set the value to 100 millimeters. Add a dimension to the top arc, and from the keyboard select the equals key, which activates equation entry mode. Now we can select the circle's dimension from the graphics view, and using the asterisk key, multiply by 0.3. Enter and enter again. As easy as that, we can create equations for our dimensions. Now note that the red symbol now presents itself on our dimension, and this tells us there is an equation attached to this dimension. We will use percentages to keep our equations simple, and next add a dimension to the vertical center line, and in the same way, let's multiply that by 0.7. Next dimension the bottom arc, again referencing the circle's dimension, and multiply by 1.2. Our first sketch is complete and we have captured its intended design intent. Everything is looking good. Go ahead and complete the sketch from the confirmation corner, which is found on the top right of our graphics view, and let's save our work. Use the icon on the menu bar or simply Ctrl S on your keyboard. In the next video, we'll extrude the created profiles. Continue to use the file you created in the previous video, or feel free to use the lessons file. What we have just done is to create a single sketch with multiple contours. With the sketch selected in the Feature Manager, I'll activate the Extrude Boss Base command from the Features tab on the command bar to illustrate this better. Since the sketch has multiple contours, SolidWorks automatically activates the Selected Contours selection box for us within the Boss Extrude properties. Now if I hover my mouse over the sketch in the graphics view, we can clearly see that we have a top, center and bottom contour. The reason we created these multiple contours within a single sketch is so we can use the same sketch on multiple feature commands and can speed up our modeling process. Use this technique as often as it permits within your design intent, but be careful not to try and cram the entire design into one or only a few sketches, since this could be more of a hindrance when needing to make changes down the line. A good modeler will be flexible and combine the multiple strategies SolidWorks offers us. Select the circle contour. If you do have multiple selections in these property selection boxes, you can right-click an entry and delete it, or right-click and clear all selections. Make sure that you only have the circle contour selected. We will be extruding in two directions with different extrude depths in this feature. For that reason, set direction 1's depth to 1 millimeter. Activate the direction 2's options by selecting this box, and set the second direction's depth to 40 millimeters. Enter and enter again to complete the command. We now have our first boss extrude in the Feature Manager. Clicking on the plus icon to the left of the extruded feature icon, expand the feature and again select Sketch 1 so we can reuse it for our next feature as well. Do another extrude boss base, and this time select both the top and bottom arc contours in the graphics view. We will extrude both contours in the same feature since their extrusion depths will be identical. Note that you do not have to hold the Control key when using Properties multiple selection boxes. Simply click on what you want to include. This time we will only be extruding in one direction, so we only need to set direction 1's properties. First, reverse the extrude direction by clicking on this icon with the two arrows. For our design intent, we want the depth of these contours to be the same depth as direction 2 of the circle extrude. Furthermore, if the extrude depth had to be changed, we want to ensure that this extrusion's depth will automatically update to the same depth. To achieve this, let's select the Up to Surface End Condition from the End Condition drop-down box. With the Up to Surface End Condition selected, the properties have now changed and SolidWorks is now asking us to select a plane or face. In the graphics view, position your mouse cursor over the cylindrical face of the circle extruded, right mouse click and activate the select other command from the right mouse options. Using this tool gives us the ability to select faces located behind other faces easily without having to rotate our graphics view, which is very handy. From the pop-up dialog, select the face, or alternatively, select the face directly in the graphics view. Complete the extrude command by clicking on one of the green OK icons. Note that if I did not move my mouse, the cursor feedback indicates that I can do a right click of the mouse to complete the command as well. Again, very efficient. Control S to save your work, and I'll see you in the next video. In the first video of this chapter, we used equations to capture the design intent of the sketch. We can visualize this using the Instant 3D capabilities of SolidWorks. The Instant 3D toggle command can be found on the Features command bar. Click on the first feature in either the Feature Manager or directly in the Graphics view. This will show the selected feature's dimensions. Blue dimensions are measurements entered into the features properties. In this case, our extruded depth. Black dimensions are what we have created at sketch level. Notice the little blue orb on the circle's dimension. I can click and drag this to adjust the dimension size in real time. Note that because of the equation constraints, as we increase the size of this dimension, the other sketch entities adjust accordingly and the profile of our flywheel looks as intended. However, notice that the 40mm extrusion depth has not scaled accordingly and has remained at 40mm. Thus, we have not captured the model's design intent fully as yet. Let's rectify this so you can see how to go about it. Do a Ctrl Z to undo. In the Feature Manager, select the first Boss Extrude feature icon, so the context toolbar will be presented. From the toolbar, select the Edit feature icon in the left corner of the dialog. Select the D1 entry box. On your keyboard, select the equals key to activate an equation entry. In the graphics view, you will note the sketch dimensions are now visible. Select the circle dimension, which is 100mm, and multiply this by 0.01. Enter once to solve the equation. Do the same for D2 and multiply by 0.4. Enter and enter again. Let's see how our model behaves now when we adjust the 100mm dimension using Instant 3D. As we now drag the blue orb, we can see that the entire model scales as it should, including the extrusion depths, and our design intent is now fully captured for this stage of our design. With some upfront consideration and planning, you can build solid models in this way. Use Instant 3D to constantly test your design as you build and constrain. Now, we do not have enough time in this course to address every aspect of our design intent in this way, but I trust from what I have shown you, you can see how powerful this can be and how important the consideration of design intent is in our modeling strategy. We will now use the revolve boss base command to revolve the front shaft of our flywheel. The reason for using this tool instead of the extrude boss base is so we can capture our required profile from a single sketch and extrude. Start a new sketch on the right plane using the spacebar key. To bring up the in-context view orientations dialog, we have easy access to the normal to icon, which rotates the graphics view normal to our screen. Note the shortcut key is Ctrl 8 if you prefer to use that instead. Select the icon for a normal to orientation. Follow my lead as I sketch the required profile. Select the line tool. Starting on the midpoint of the front edge of the underlying geometry, sketch a vertical line, then a horizontal. Add a couple of steps similar to this. Add another horizontal line, then a vertical line down till we are perpendicular with the origin, which is denoted for us by the blue inference line, and then back to our start point. Note that the reason I started on the front edge of the existing extrude and not on the origin is so the front shaft will maintain its length relevant to that face if the underlying extrusion depth had to change. If we use the origin instead, it would simply be fixed by that and give us undesired results. Escape to cancel the active command. Make the first steps vertical and horizontal lines equal to each other. So we only need to apply one dimension. Select the Smart Dimension tool, set the right vertical line to 43 millimeters, the top horizontal line to 64 millimeters, step 1 to 6 millimeters, step 2 to 12 millimeters, and this horizontal line to 54 millimeters. From the Features tab, select the Revolved Boss Base command. Note the Axis of Revolution box is pre-selected in the command's properties, since we need to specify an axis. Whenever I am adjusting feature properties, I prefer to change my graphics view to the default trimetric view, so I can properly see the result of my extrusion for additional adjustments if needed. We will select the bottom horizontal line in the graphics view as our axis of revolution. Complete the command. On the front face of the newly created extrusion, we will create another extrusion. With the face selected in the graphics view, from the context toolbar, select the sketch icon. With the face still selected, select the Convert Entities command, which automatically creates a circle from the underlying geometry. Now, if the underlying geometry changes, so will the sketch. Do an extrude. Make the length 32 millimeters with a draft of 8 degrees and complete the command. Note I activated the draft dialog by selecting this draft icon. Let's do the back shaft while we are at it. On the back face of our flywheel, start a new sketch and sketch a circle with its center point vertical to the origin. Create a vertical relation from the center point to the origin so the circle is constrained in that position. Make the circle equal to the top arc. Dimension the circle 60 millimeters from the origin. Extrude the circle 50 millimeters. And your model should now look like this. We'll leave it at that, and I'll see you in the next video.